We're going to finish chapter 3 today. We are going to talk a little bit more about annuities as well as loans, mortgage payments, stuff like that. To start, we're going to talk about what's called the present value of an ordinary annuity. So this is where we want to deposit money today or eventually reach some goal so that we can withdraw. This is kind of like retirement, withdraw a scheduled amount over a set of time. So you want to have or be able to withdraw like $1,000 a month for 15 years when you retire, something like that. So we have a formula that says PV, present value, is equal to the payment, aka the monthly withdrawal amount, times 1 minus 1 plus interest rate. Remember, that is R over M, raised to the negative n power, all over I. An example, they may just tell you what NI payment are and ask you to find the present value. Most often, though, it's going to be written as a sentence word problem like the second example there. So we start with this first one here. Present value equals, I want to be able to withdraw $200. The interest rate on the account is 4%, and I want to make 30 $200 withdrawals. So 1 minus 1 plus 0.04 to the negative 30 all over 0.04. So I'll grab my Desmos calculator. 200 times the fraction 1 minus open parentheses 1 plus 0.04 close parentheses raised to the negative 30 all over 0.04. The value it gives us is $3,458.41. So basically saying if I were to deposit this much today, I could withdraw $200 30 times. And at that point, then the account would be empty. American General offers a 10-year ordinary annuity with a guaranteed rate of 6.65% compounded annually. How much should you pay for one of these annuities if you wish to receive payments of $5,000 annually over a 10-year period? All right, we have $5,000 is what we want to be able to take out. 1 minus parentheses 1 plus 6.65, so 0.0665 annually. So I don't have to, dividing by 1 doesn't change my answer there. I'm going to raise that to the negative 10 power because I want to do this 10 times. And then 0.0665 is going to be on the bottom. So this says if I deposit today $35,695.18, I'll be able to make 10 $5,000 yearly withdrawals. Now we're going to talk about loan amortization. When you have a loan, you decide how much you're borrowing, and based on that and the interest rate and how long you have the loan for determines the monthly payment that you have to pay back your loaner. Or your lender is the correct term, I believe. So Your loan payments can be calculated by taking the amount of the loan times the rate of interest divided by 1 minus 1 plus I to the negative n power. First one says the present value of the loan is $40,000. You're going to make 96 payments and the interest is 0.0075. So how much is each individual payment? So payment equals 40,000 times interest 0.0075 all over 1 minus 1 plus 0.0075, and that is going to be raised to the negative 96th power. Set up my fraction, 40,000 times 0.0075, 1 minus 1 plus 5 to the negative 96. Oh, I have an extra 0 here. 40,000. There we are. I accidentally typed 400,000. All right, our monthly payment is $586.01 if I round that. Now, we made that payment, so 586.01, we made that 96 times. So the loan that we took out for $40,000, by the time we're done paying it back, we've actually paid $56,256.96. So because of interest, you end up paying an additional $16,256.96. Now, there are always ways that if you have a loan that you take out, that you can reduce this amount of overpayment. So if you've never taken out a loan before, ways you can do that is, one thing depends on how long you take it out impacts your interest rate. So there's balance of calculating if I can get a lower interest rate by having the loan less time. Your monthly payment may be a little bit more, but you're going to, in the end, because you have the loan less amount of time, will pay less in interest. There's other things you can do, like paying an additional yearly payment. So like come the end of the year, you make an additional payment and that pays down your principal. My husband and I take the approach of, we always add an additional, $200-300 to the loan each month. So our house mortgage has gone down in the length of time. We had I think initially like a 30-year mortgage. But because every single month we put down an additional $200 every time we pay that, that brings down the principal a lot faster. I'm paying down the loan faster. So I'm in the end paying less interest to the bank. So always want to look at those kinds of things, figure out how much you're actually paying in interest and how you can reduce that if you have the means to do so. If you buy a computer directly from the manufacturer for $2,500 and agree to repay it in 48 equal installments at 1.25% interest per month on the unpaid balance, how much are your monthly payments? And then how much total interest will you then pay? We have payments equals 2,500, and this is already calculated as how much you're paying per month. So I don't have to divide this by 12. This is already my monthly interest. So 0.0125 1 minus 1 plus 0.0125. We're going to do that 48 times. So just so you know, if it's 1.25% monthly, that's 15% for the year. So while that looks low, when you actually calculate it in terms of the year, that's actually a pretty high interest rate. So always, always, always read that fine print. Sit and calculate if you are going to purchase a car so that you can have them tell you, okay, this is how much I'm taking the loan for. This is going to be my interest rate. This is how many payments. Get that. Figure out how much interest you're paying. Ask them about the next option. Figure out what works best for you to pay the least amount of interest. So 2,500 times 0.0125 all over 1 plus 0.0125 to the negative 48 power. So your monthly payment is $69.58. Okay, so remember, your loan was for $2,500. We paid $69.58 48 times. So if I just do that really quick, $69.58 times 48 means in total I pay $3,339.84. So I paid, if I subtract these, I pay in interest, it's paid minus loan, $839.84 extra to do that payment plan versus buying it outright. Next example, you want to purchase an automobile for $27,300. The dealer offers you 0% financing for 60 months or a $5,000 rebate. If you take the rebate, you're then going to obtain 6.3% financing for 60 months at the local bank. Figure out which is the best option. Okay, option one, if you can get a 0% financing, it means you're not paying anything additional. Your loan is what you pay back. There are no fees. So $27,300 is what you're going to pay back. Now, option two, instead of paying outright, you decide to take the $5,000 rebate. So they take the initial cost of the car less the rebate. So they're going to take $5,000 off that, meaning you owe $22,300. You are going to finance that for 6.3% over 60 months. So we got to do the work here. Payment equals $22,300 times, this is what I need to do because this is the annual rate, 0.063 over 12. 1 minus 1 plus 0.063 over 12, and then that's going to be to the negative 60 power. Once I get this result, I'm then going to times it by 60 to figure out how much in total I've paid. Raise it to the negative 60 power. So my monthly payment is $434.24. $434.24. but I make that 60 times. Meaning, in the end, I've paid $26,054.40 for the car. Let me put this out here. It was $434.24 times by 60 gets me to $26,054.35. Comparing those two values, which one was the better option? Option 2. 26,000 is less than 27,000. So this would be the option you would take. Again, another example of things you want to think about when going in to purchase a car. Your dealer is going to have their bank that they work with and their interest rates. So while they could offer you 0% financing, knowing your local bank's options as well is also beneficial to you. Questions on those? On the next slide, we are going to show or work through a loan amortization schedule. We will never do a very long one. I just like to kind of explain the process so you understand how, if you ever get a loan or look at a loan table, you understand how each part is being calculated. Basically, what it's going to show is the amount you're paying monthly, how much of that is going towards interest, then how much is being then deducted from your balance, and then your balance. All right, so it says to construct the amortization schedule for a $5,000 debt that is to be amortized in 8 equally quarterly payments at 2.8% per quarter on the unpaid balance. So when I start, my unpaid balance is $5,000. You are going to figure out your monthly payment first, just like we've been doing. So 5,000 times, it's 2.8% every quarter. So 0.028, it's already figured out per quarter, so I don't have to divide anything. 1 minus 1 plus 0.028 to the negative 8 power. Now, I trust I've shown you a few examples. This comes out to be $706.29. I would hope at this point you could plug that in and get our answer. So what I'm going to do, payment 1 is $706.29. Then we're going to work our way through. So it says then to take interest takes the previous balance times interest. So the previous balance is $5,000. If I take 5,000 times the interest rate, 0.028, $140 is paid towards interest. Now we calculate the balance reduced. Take your payment minus your interest. So 706.29 minus 140 means that $566.29 is going to go then towards your principal. That is how much your balance is going to be reduced by. So then I can take that 5,000 minus the 566.29, and my remaining balance as of now is $4,433.71. My second payment is exactly the same, $706.29. My interest is not going to be the same though, because the interest is calculated on your previous balance. So I take that $4,433.71 and I times it by 0.028. And I get $124.14. You do the subtraction here. This minus this is going to get you to your how much your balance is reduced. $582.15. Then you subtract this from your previous balance, $3,851.56. Process continues. I pay another $706.29. I need to calculate how much is going towards interest. So I take previous balance, $3,851.56, times by 0.028. This time, $107.84 is going to interest. You subtract that from your payment, $598.45 is now going to your principal, or going to reduce your unpaid balance. So when you do the subtraction, we are now down to $3,253.11. Okay, I'm not going to make you go through all of these here. So I'm going to fill in the table for the next 4 rows. Again, it follows the same process every time. So 9109, 7386, 5615, 3795, 61520, 63243, 65014, 66834. This drops down 2637.91, 2005.48, 1355.34, 687. Anytime you have a loan, your last payment is usually just a little different than what you've been paying every month. So the question is, how do I determine that? Well, we want, in the end, to pay off the full $687 balance. We can calculate the interest that I would pay on that $687. So 687 times 0.028 is going to be $19.24. And then I can work backwards and say these two have to add to give me what I'm paying. So when I add those, it's $706.24. So anytime you're doing one of these loan tables, the very, very last row is almost done backwards because your payment is going to be slightly adjusted. You could calculate total interest by summing the whole interest column here. We paid $650.27 in interest. Some friends tell you they paid $25,000 down on a new house and are to pay $525 per month for 30 years. If interest is 7.8% compounded monthly, what was the selling price of the house? And then how much interest would they pay in those 30 years? So we have 2 equations. Present value equals payments times 1 minus 1 plus I to the negative n over I, or payments equals PV times I over 1 minus 1 plus I to the negative n. We have our payment and we are looking for our present value. We're going to use this top equation. So present value equals 525 times 1 minus 1 plus 0.078 over 12. Now we're doing 12 times a year for 30 years. That's going to give me 360 times over 0.078 over 12. We take 525 times 1 minus 1 plus 0.078 over 12 to the negative 360 over 0.078 over 12. We get the loan amount of $72,929.78. $72,929.78. So that's the loan. They also paid $25,000 as a down payment. The loan plus the down payment give you your total sale price of the house. So if I add those up, I get $97,929.78 was the sale price of the house. If I want to find interest, that's going to be what I paid minus the loan. So we paid $525 360 times minus my loan amount, $72,929.78. So 525 360 times means I paid $189,000 for that $72,900 loan. So subtract 72,929.78. I paid $116,070.22 in interest. Last thing we're going to do is I'm going to show you a loan amortization website. So it says a family has $150,000 30-year mortgage at 6.1% compounded monthly. Find the monthly payment. And then you can find things like total paid towards principal, total paid toward interest, total paid overall. You can find remaining balance at a specific point in time of that loan. So in our week 14 folder, I have the first link under there. It says loan amortization table. And it takes you to this lovely guy here. So what we can do is we can enter in what we want. So the loan was for $150,000. It was for 30 years. And the interest rate was 6.1%. I'm then going to hit calculate. What it's going to do here is it's going to show you how much you're paying monthly right here. And then your breakdown of how much is going towards interest, how much is going towards principal. So on this loan, you end up paying more in interest than you do towards your principal. So your loan was $150,000. You pay $177,000 in interest. You are paying double the price of the loan by doing this. Now there's a neat little graph here on the side that shows you how your payments sum up over time, how your principal decreases, or sorry, your balance decreases over time, and the amount you're paying towards interest over time. Now, there is an annual schedule here, or I could do a monthly schedule if you really wanted. It breaks it down by every month or every year. So it said, how much is the loan balance after 10 years? Well, that's right here. After year 10, here's my loan balance. If they want to know after 20 years, I go down to 20, here's my loan balance. So $81,506.90. Now, here's where this gets really interesting, just to show you. If you want to make extra payments, So you can see how this impacts you. So let's say every month you add another $200. You can see then the amount of interest you save and when you'll actually pay off your loan. So there's ways you can see here, okay, you're going to pay your 30-year mortgage loan in 19 years and 2 months, and you'll save $72,000. Okay. If you're not able to afford a monthly payment, maybe you just make an extra yearly payment of $1,000. You can see what happens and how much you can save and how much faster you'll pay off your loan. So things like this are, again, really practical to understand, and things to definitely think about. Anytime you can pay extra to a loan, it clearly helps you in the end for how much you're actually paying back. So I did want to show you that part. And you can do that with any loan question we did. So if it just asks you, I think in the homework we have questions that'll say, like, if they say, all right, you have a $225,000 loan. Your loan is for 25 years and your interest rate is 4.25%. I'm not going to make any extra payments here. So if they just say, hey, what's the monthly payment? You can use this here. It'll calculate it for you on the side. If it asks, how much is paid in interest? It's going to tell you that right here. Total paid in interest is $140,673.22. If you ever want to find a balance at the end of the year, you're just going to use your entire table over here. All right, this is our last question for today. Our ordinary annuity pays 7.44% compounded monthly. A person deposits $100 monthly for 30 years and then makes equal monthly withdrawals for the next 15 years, reducing the balance to zero. What are the monthly withdrawals and how much interest was earned during the entire 45-year process? This is a two-part problem. We are starting with making $100 deposits every month for 30 years. So we're going to go back to what we did last week for a future value. $100 times 1 plus 0.0744 over 12. I don't know why my decimal got put down there. Because we are compounding interest, we are going to have a positive exponent of 360 minus 1 over 0.0744 over 12. And again, if you ever get stuck remembering what formula works for what, you do have that chapter 3 formula sheet you can always look back at. So 100 times 1 plus 0.0744 over 12 to the 360 minus 1 over 0.0744 over 12. So the first part of this problem is you're depositing these $100 every month for 30 years. That makes the account worth $133,137. And then from there, I want to withdraw monthly for the next 15 years. So I'm using that money monthly till it all goes away. I can find my payment by taking 133. Oops, I added an extra 3. 133, 137.0744 over 12. 1 minus 1 plus 0.0744 over 12. It's the negative. Let's think this through. 12 times a year times 15 years is 180. $33137. 0.0744 over 12. 1 minus 1 plus 0.0744 over 12. Negative 180. All right, so I will be able to withdraw $1,229.66 every month for the next 15 years. 122966. 122966. Okay, so by setting aside $100 a month, after 30 years, I could actually withdraw 12 times that amount for the next 15 years every month. The last question then says is how much interest did you earn over this entire period? So the way you do this, interest is equal to total withdrawal minus total paid in. We took out $1,229.66 180 times. I only put in $100 times $100 360 times. So if I go here, that was 122966 times 180 minus 100 times 360. I earned $338.80 in interest. You only put $36,000 into your account. This right here was the 36,000. And I ended up with $338.80 worth of money in the end. So let's see. That's 6 times the amount and some change of what I put in. So I'm hoping you can see the practicality of this and things that you can use just in general life and see the benefit of maybe setting up an account now for your future.